idea. So amines. So what you're about to hear is about amines, obviously. You need to be able to draw the structural formula of the protonated form of amine, given the structural formula of its molecular form, and vice versa. So again, it's a bit of nomenclature, and also, well, you being familiar with structural formula again. Second one, identify an amino group in an amine as primary, secondary, or tertiary, given the structural formula. Now, if you could do this, it could do the same thing for alcohol. It's pretty much the same. Okay. Thirdly, explain why some drugs with amine groups are usually taken in the form of their salts. Very similar to what you heard in carboxylic acid as well. All right. So here are general structures for amines. Amines may be regarded as derivatives of ammonia, in which one or more of the hydrogen atoms of the ammonia molecules have been replaced by alkyl groups. So if you look at the 4 general formula there, ammonia, which you should know as NH3, is there, right? Now, if the nitrogen is bonded to any carbon instead of 3 hydrogens, you get amine. Now, do you see the primary amine has got 1 carbon attached to nitrogen? If you remember, R means any length of carbon, yeah? Yeah. An amine group could be like a branch, or could be at the end of a chain. It really depends on which amine you're talking about. Okay. Secondary group, hope you can see 2 R's there, 2 alkyl groups, and tertiary, you've got 3 alkyl groups, right? So that just defines primary, secondary, or amine. How many carbon friends that nitrogen have? That's really that. Okay. That's the classification. Oops, it's on there. So amine acts as base. Now, hopefully you know that ammonia is a base. Yeah, NH3 can become NH4. Yeah. If you look at essentials page 265, there are 3 protonation that you can find. So 265, 265. And I would like you to copy that. So starting with N here. Now, methanamine that you can see in the first box there, you agree that that's a primary amine? There's 1 carbon chain there attached to nitrogen. Yes. Now, when it accepts proton, what's going to happen? It gets protonated. But where does it attach to? So if it's ammonia, NH3 can become NH4, right? Okay.
So
yeah.
losing.
Yep. Well, that's pretty much that too. I might just use this instead. Nitrogen will cause, according to Vesper theory, the non-bonding electron pairs can also cause the electron cloud that pushes these bonds down, right? Now, that lone pair of electrons, non-bonding electron pairs, they can also act as a place where hydrogen can bond to. So if protonation occurs, the H could be bonded to nitrogen. The only thing you might want to be careful with is where the plus sign occurs to show that that's positively charged as an ion now. Where does the plus sign occur in the diagram? Nitrogen? Yep. Hydrogen is, of course, positively charged, and nitrogen is the one having, I guess, less electrons around now. Hope that makes sense. So nitrogen is the one that's positively charged. Yeah. So that was the primary amine one. And you can also do similar things with secondary amine. If protonation occurs, so adding H plus, adding H plus. Now you have nitrogen here, extra hydrogen here. This is supposed to be R dash. Very similarly, nitrogen is the one that's positively charged. And if you have tertiary amine, and again protonated, what's going to happen? Follow the same pattern. So you have now protonated all that. 265. Now, one I guess important thing to remember is, well, you need to be able to draw these structures, but you don't have to be able to name these structures. Okay, naming amine compounds, because it starts with like N, things like that. You don't need to be able to do that. All right, don't worry about naming of it. All right, moving on. So that's amine acting as base. Now, remember the carboxylic acid part. When a carboxylic acid compound is very big, it doesn't dissolve. Yeah? But carboxylic acid can be found in food or medicine quite often. When it's taken as medicine, it usually comes with sodium bicarbonate. Sodium carbonate or some sort of carbonate ion in it. All right. What does it do again? So you've got acid and base, really. And if you mix acid and carbonate, what happens? Oops. If you have acid and carbonate, what happens? Carbon dioxide. Yes, you get the bubbles. What do you call that effect again? That's the one, effervescence, right? Amine usually appears in a very big compound as well, but when it's charged, when it's ionized, all right, it can also dissolve into water, just like big molecules of carboxylic acids. Okay. So it is important that, well, if amine is part of, say, medicine, it it's administered with acid. Okay. Because how do you protonate a base? Well, you need an acid. Okay. All right. So the salts of amines are soluble in water because of the ion-dipole interaction that can happen between this ion of amine and also a water molecule. All right. Make sure you can draw the interaction. Same deal as usual. You use dotted line to show that the positively charged part, again, it's nitrogen. Yeah, that's being positive, and that's interacting with oxygen. So connect them with broken dots, dotted lines. All right. All right. Question. Draw the structural formula of the protonated form of procane below. Where would you protonate?
The left side.
Left hand side or right hand side? Left? Let's go with left because that's correct. Yeah. One thing that you should also know in the back of your mind is that if you've got benzene group, they don't get, sorry, the nitrogen that's attached to benzene group, they don't get protonated so easily. Okay. Whereas if you have got smaller carbon groups attached to nitrogen, it's easier to, much easier to protonate. All right. So in this case, you have to draw the whole thing, add another hydrogen attached to the lone pair of electron there. Okay. And make sure you have the positive sign at where? On nitrogen. All right. So draw that just below it, next to it.
Wait, so the whole thing you want us to draw?
Yep.
With the carbon chains go up more with the hydrogen?
Yeah, you can do like that carbon pointing upwards, the other one going down, and hydrogen here. Hmm. So I guess in that structural formula, the biggest hint was the lone pair of electrons, the non-bonding electron pair that was appearing there. And again, make sure you have a positive there. All right, next question is saying classify procane as primary, secondary, or tertiary amine.
Tertiary.
I would go with tertiary too. Well, depending on which amine group that you're looking at, right? So this one originally, what would that amine part be? Well, I think you were all looking at that one first. That would be tertiary. Yep. How about this end now?
Primary.
Primary. Nitrogen's only bonded to one carbon. Yeah. So this is a carbon here. So that amine group itself is a primary. Finally, explain why some drugs with amine groups are usually taken in the form of their salts. Because it dissolves in water well. Yep. Due to?
The ion interaction between salts.
Yep. How do you call that interaction again? As what? That's the one. Just a specific term that you should be able to use, that's why. I think I took these three questions from one of the old exams. So you're already doing final exam question. So as long as you understand just the theory and how protonation works and interactions between ions and water, how that works, you can answer all these questions. Right. Why don't we do some other questions up to page 267. So you should be able to do questions up to page 267.